Hi guys! Today we are actually going to start a new chapter of trigonometry, but instead of going over the textbook, I think I'm going to just pick certain objectives that are quite important to understand trigonometry, and then we'll have homework problems based on the worksheets that I choose. Okay. So today, my main objective for you guys is just that you can convert the degree measurement, which is the angle measurement, to a radian measurement, which is another type of angle measurement that actually mathematicians prefer more than the degrees. And then we are going to look at something called unit circle based on the radians and degrees and trigonometry. So this video might get a little longer than 15 minutes. Hopefully I will finish it up in 15 minutes. So let's talk about radian measurements. Let's talk about degree first. So degree has this symbol, right? So if I say 30 degrees, you know about approximately how much that is, right? And the circle has a 360 degrees because the straight angle has a 180 degrees. And circle is basically two straight angles added together in the middle that we know that it's 360 degrees. So the idea of radian came when people were thinking about what if we just measure how much radius is going to take in a circumference. So they are just looking at the radius and circumference and trying to figure out what the angle would be. And just like pi, radian happens to be the same every time because if you think about it, the circumference itself is made of radius, right? Because circumference is 2 pi r, so it has a 2 pi times the radius measure, whatever that is. So we're going to think of the radius to be 1 because that is the easiest one. So whenever your radius is 1, we call that circle a unit circle because that is the simplest circle you can draw. And radian, unlike degrees, does not have any unit. Meaning, if you write just 30 without the degree symbol, if there's no degree symbol, I'm going to read 30 as a 30 radian. Okay, so you need to be very careful to write this little unit to indicate that it's a degree or radian, because without that, it will be radian automatically. So let's talk about the circumference again. I told you the circumference of a circle is 2 pi r. And r here is 1. So that means this circumference is 2 pi. Okay, so that means half of a circle, this part, would be pi. And also this half would be pi, right? Because then when you add them up, it becomes 2 pi. Wait. But we know that this much is 180 degrees, right? So that means you can create a ratio. 180 degrees is a pi, okay? So for you to find degrees for you to find the radians from degrees, what you can do is this. You have a certain degree measurement, right? You multiply that to pi over 180 degrees. So then you can cancel out this degree symbol and x pi over 180 would be your radian measurement. If you want to go from the other direction, let's say you're trying to find radians to degree. So then you do x radians times 180 degrees over pi. So whatever you want to cancel goes in the bottom. So then this becomes 180 x over pi degree. Okay? So let's fill out partially of our unit circle. I know this looks very complicated, but we're going to only fill out the degree portion and the other portion first. Alright, so this part, because we measure the angle like this, we have a straight line, and then you measure like from that line to the left side, right? So this angle right here is a 0 degree, right? Because there is no angle right now. And then we know that this is 90 degrees because it's going to make a right angle right here. And then this would be 180 degrees. So I'm just filling out something that's easy for me to fill out first. And then 180 plus another 90 would be 270. And then when you make, I'm not writing the degree sign because it's there. When we make a full circle, it's a 360 degrees right here. Okay, let's look at 1/4, so quarter of a 180. So if you have a 90 degrees here, and if you divide it into 2, right? Like right here, that's the middle line. Then it would be half of 90 degrees, which is 45 degrees. Meaning that this much is 45 degrees. So then when you add 45 degrees to 90 degree, that would be 135 degrees. And then if you add 180 degrees to 45 degrees, right, because this would be a straight line, 180 degrees, that would be 225 degrees. And then 45 degrees less than 360 would be 315 degrees. Does it make sense how I'm looking for all these answers? And then we're going to look at 90 degrees being divided into 3 portions. So do you see 1, 2, 3? So that means that 90 divided by 3 would be 30 degrees. And I have 30, 60. So this would be 60. 90, and then add 30 again, 120. Add 30 again, 150. Add 30, then 180. Add 30 to 10. Add 30 to 40. And then I add 30 again, it's 270. Add 30, and then 30. So we made a full circle again. Easy enough. Essentially, for more advanced math classes, you will have this circle memorized completely in your head. It is true that your calculator can do this, but that takes so much more time to kind of figure out what radians go with which degrees and things like that. So for easier or faster math problems solving, you will want to memorize this eventually, okay? Right now it's silly because I can give you a quiz, but you could look at your notes, so I'm not going to do that, but just know that next year you probably want to have it memorized. So let's talk about the radians now, the other line that goes next to the degree. So 0 radians would be 0 degree. Right? And then we already talked about 360 degree would be 2 pi. 180 degrees then would be half of that, so it would be pi. And then 90 degrees would be half of pi, so pi over 2. So it's a fraction, guys, and that's why you might not like this, but it's just a fraction. And from pi over 2, I'm adding a pi because that's a 180 degrees, right? So it's a 3 pi over 2. Right? Because pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. When you simplify all of that, you get 2 pi, pi over 2 pi, and 3 pi 2. Half of pi over 2 would make pi over 4. Right? So then let's do this again. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which makes it pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4, which makes it 2 pi. All right, let's look at, I don't know if you can see yellow, but we'll try. Pi over 2 be divided by 3. So it's pi over 2 divided by 3, which is the same thing as pi over 2 multiplied by 1 over 3. So it then makes pi over 6. So this right here would be pi over 6. Just like we added 30, so let's think of it that way. Pi over 6, and I add pi over 6, which is 2 pi over 6. But 2 pi over 6 can be simplified to pi over 3. And then I add another, which is 3 pi over 6, which simplifies to pi over 2. 4 pi over 6 would be 2 pi over 3. I'm just simplifying everything. And then 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6. 10 pi over 6, which is 5 pi over 3, 11 pi over 6. And that's it. Do you see how there is a pattern to everything? So you will see pi over 6, pi over 4s, pi over 3s, and pi over 2s, okay? But in reality, really there's only pi over 6 and pi over 4. The other ones are basically simplified version of pi over 6s and pi over 4s. So if you can remember that, this graph wouldn't be that hard to memorize, okay? All right, you might be wondering what this is. So you have to imagine that this circle being in an x-axis and a y-axis. And this point right here, the center of the circle is 0, 0. And we said that this was a unit circle, right? What that means is that this radius is 1 unit long. So then we can actually come up with a coordinate point for each of the angle that we just described. So let's do, I'm gonna try to use a different color. But I don't know if the sparkly one is actually nice for you guys to see or not. I'll do purple. All right, so here the x coordinate will be 1, right? Because this is 1 unit long, and then y, there's no length, there's no height, right? So it's a y, 1, 0. This point on the other hand, x is 0, right? Because this is 0, 0, and y is 1. This one is going to the left side, meaning that it's entering a negative realm, right? So we're gonna write -1, 0, right? Because x is -1. And then down here, x is 0, but y is -1, okay? So for today, I think that's where I'm gonna stop, and then we're gonna fill out the rest of these guys. You might be wondering, how do you find values for those? That's what we're going to talk about tomorrow. And today, as long as you understood how I got the values for each of the the angle value, obviously, if you do degrees, and then you can convert each degree measurements to radians. But I think it's silly because it's actually a lot more time consuming, right? Because let's say I didn't know if 30 degrees was pi over 6. Then what I do is that I take 30 degrees and multiply by the multiplier pi over 180 degrees because I want to get rid of the degrees so the degree goes down. And it's always pi over 180 or 180 over pi. So then it's just 1 and 6, so it reduces to pi over 6. So if this is easy for you to do every time, do it, but I think these angles are seen enough that you will eventually memorize them, okay? So when I say, okay, what is a 135 degrees in radians? You can just say, oh, it's 3 pi over 4, right? Instead of, oh, let me try 135 degrees times pi over 180. Then you need to simplify again, and it's just not as quick as having it memorized. It's like having times table memorized. You don't always try to do what's a 2 times 8, like by hand or a calculator. You tend to have it memorized. Not because it's something that you find it fun to memorize, but it does make your math a lot faster, right? And I think oftentimes math gets frustrating when you don't have those basic things memorized because every time is a hard work for you because I can just do it like this and you'll be like, oh, I need to figure out what 2 times 8 is before I actually get into what we are learning about. So I think unit circle is the times table for pre-calculus and beyond. Okay, so I would recommend you to study this circle because it is, you will easily, you can come up with your pattern to fill out this, and I often give my students 5-minute time limit to fill out the entire unit circle. And in the beginning, they all panic, but they do manage and they think, oh, that wasn't so bad, and it was very helpful in the end. And so today, we just learned about how to change from degrees to radians and radians to degrees, and then filled out partially of our unit circle that we are going to focus more on tomorrow. So I will see you tomorrow with the new lesson.